Ladies and gentlemen, to formally start this event, we have the honor of listening to welcoming remarks from our distinguished guests. Now I have the pleasure of introducing Associate Professor Dr. Supandi. He is the Dean of the Faculty of Education of Mathematics, Science, and Technology Information. Will share his valuable insights in the opening remarks. Please welcome Bapak Dr. Supandi.
Okay. Thank you so much, uh, Dr. Karnita. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Good
warahmatullahi
afternoon and
wabarakatuh.
warm greeting to everyone present. I think that's good morning in Ghana. The Honorable Professor Hans, Dean of the Faculty of Math Science and Mathematics Education, Appiah Menka University of Skill Training and Entrepreneurial Development, Ghana. The Honorable of Dr. Prayito, Head of Department Mathematics Education, UPGRIS Semarang, the Honorable Prof. Ebener Bonya, Assistant Prof. Dr. Widyagun Sumaningsih, and Ms. Camilla Alisha, our distinguished research speakers, esteemed participants both from within our country and abroad, Ghana. Distinguished guests, we offer our sincere gratitude and praise to God Almighty for the opportunity to gather today in the significant event, the International Joint Series on Mathematics and Mathematics Education 2025. This event symbolizes a truly meaningful collaboration between two nations, it means from Indonesia and Ghana, in the field of mathematics and mathematics education. Ladies and gentlemen, mathematics is not only a subject taught in school, I think so, that it is a vital tool that foster critical thinking, logical reasoning, and provides solution the merit college challenge we encounter in our everyday lives. We are deeply appreciative of the presence of the resource speaker from Indonesia, who will generously share their insight into the development of mathematics and mathematics education in our homeland. Likewise, we are grateful for the experts from Ghana, whose unique perspective and experiences will undoubtedly enrich our understanding. This collaboration offers us an extraordinary opportunity to learn from one another and enhance our collective knowledge of mathematics education at the international level. Throughout this event, we aspire to strengthen academic and professional network between Indonesia, Ghana, and other nations. We are confident that throughout close collaboration, we can work together to find innovative solutions to the challenge facing the field of mathematics education and contribute to the creation of a better educational system in the future. In the closing, I extend my best wish to all participants in the International Joint Series on Mathematics and Mathematics Education 2025. May this event bring immense value to all of us in terms of knowledge, experience, and above all, the strengthening of international relations. Thank you, and may this event proceed smoothly and successfully. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Supandi, for your enlightening words. We truly appreciate your presence and the wisdom you have shared. Ladies and gentlemen, without further ado, we have the honor to listen the welcoming remarks from our distinguished guests. Now I have the pleasure of introducing Professor Zarhans Diso Arthur, the Dean of Faculty of Applied Sciences and Mathematics Education, AAMUSTED, Ghana. He will share his valuable insight in the opening remarks. Please welcome Professor Zarhans.
Thank you very much, the moderator. And I want to use this opportunity to thank my colleague, Professor Ebenezer Boya, our Director of International Affairs of the Akenten Appiah Menka University of Skills Training and Entrepreneurial Development, and a very renowned professor in the area of mathematics education in the world. And for that reason, I want to say that I'm very honored as the Dean of the Faculty of Applied Mathematics Education to be part of this international joint lecture on mathematics and mathematics education. I must say that mathematics is the basis of creation. And if mathematics is the basis of creation, then how we tackle mathematics and mathematics teaching is crucial to the very existence of humanity in the world. I must say that when Allah created heaven and earth, he used mathematical language. And for that reason, if mathematics is the language that God used in created heaven and earth, then every humanity must respect the concept of mathematics. And it is not surprising that in every part of the world, mathematics plays significant role from the very basic to the topmost of the university echelon. And for that reason, I think that beginning such collaboration within Indonesia and Ghana is very strategic. And I think that the professors who came together to bring this collaboration must be recommended. And we must also say that we all should support their ideas and whatever inspiration they got in bringing this collaboration and this joint lecture together to survive and succeed, so that students, lecturers, and staff of the two universities will actually benefit from it. I must also say that let this not be the beginning and the end, but this beginning should actually spike a higher height in collaboration, so that we can even have a joint collaboration, not just in research or not just in presentation, but possibly we can even have student exchange, staff exchange in different directions in the use of mathematics in advancing careers in the various parts of our university endeavor. Let me use this opportunity to just share a little light on Akenten Appiah Menka University of Skills Training and Entrepreneurial Development. Must say that Akenten Appiah Menka University of Skills Training and Entrepreneurial Development is the youngest university in Ghana, and we are specifically created to deal with TVET education. And the Faculty of Applied Sciences and Mathematics Education is the biggest faculty in Akenten Appiah Menka University of Skills Training, with about close to 8,000 students in the faculty. We have two departments: Department of Information Technology Education and the Department of Mathematics Education, where Professor Boya and myself are staff of that department. I must say that the Department of Mathematics Education, though somehow the youngest department in the university, but it is the most growing faculty, and strategically it runs from undergraduate to PhD level. And I am not surprised that this joint lecture will also lay the foundation of us as two institutions or the universities that are together to also have joint supervisions, joint publications, and all those things that will advance the course of our students and advance the course of our staff. Without wasting much time, and with all attentions on our speakers, let me use this opportunity. Thank you for the opportunity. And I want to also extend the greetings of my Vice Chancellor, Professor Kwaku Safo of the Akenten Menka University of Skills Training and Entrepreneurial Development, to all participants who are listening here now. On this note, I want to thank you, and we are all ears to listen to our speakers. Thank you very much.
Wonderful. Thank you, Prof. Yerhans Tiso Arthur. That's really interesting to listen your opening speech, knowing how AAMUSTED was established in Ghana as the quite new university over there. We are also delightful to have such collaboration and wait for the further and many collaboration later. So, ladies and gentlemen, we are at the end of the opening session. We would like to invite the distinguished guests, the dean of both university and the resource speaker, and all the participants to have the group photo to capture this memorable occasion. Okay, please wait for my instruction. Professor Bonya and Professor Yarhans, okay. Professor Bonya. All right. So I will count 1, 2, 3. All right. And for the next slide, okay, please open the screen, all the participants. 1, 2, 3. Give your best smile. Okay. All right, the last slide. 1, 2, 3. Okay, all right. Thank you, everyone. Okay. For the distinguished guests, we would like to say thank you for gracing this occasion with your presence, and all the participants, distinguished speakers, esteemed dear colleagues. I'm honored to moderate today's international lecture series in Mathematics and Mathematics Education 2025. And without further ado, let us begin the plenary session of our distinguished speakers that filled with innovation, collaboration, and transformative ideas. Today we have three incredible speakers who will share their expertise. The first one is Dr. Widya Kusumaningsih. She's coming from Universitas Persatuan Guru Republik Indonesia, Semarang. And our second speaker is Professor Ebenezer Bonya. He's coming from the Appiah Menka University of Skills Training and Entrepreneurial Development, AAMUSTED, Ghana. And our third speaker, Ms. Camelia Alisa from Universitas Persatuan Guru Republik Indonesia, Semarang. So each speaker will have around 20 minutes for their presentation, followed by a discussion session. Okay, before we begin, I want to remind all attendees about the webinar etiquette. Let's ensure a smooth and respectful virtual environment for everyone involved. First, please keep your microphone mute when you are not speaking to minimize background noise and ensure clear communication during lectures and Q&A sessions. Second, feel free to chat feature to ask questions, share resources, and engage in relevant discussion. The moderators will monitor the chat and address any queries or concerns. Lastly, let's maintain a professional and respectful atmosphere by avoiding disruptive or offensive behavior. Embrace diversity and different perspectives, create an inclusive and welcoming environment. Thank you for your cooperation. Now, ladies and gentlemen, let's continue with our program. We will introduce our first speaker, Dr. Widya Kusumaningsih. She will deliver the topic talk, entitled Spatial Geometry for Junior High School Students based on local wisdom with Dr. Vidya's remarkable background. I would like to read her background. So, Dr. Widya Kusumaningsih is an assistant professor in mathematics education at Universitas Persatuan Guru Republik Indonesia Semarang, where she has served since 2006. She holds a doctorate in mathematics education from Universitas Pendidikan Indonesia. Her research focuses on ethnomathematics, realistic mathematics education, and data numeracy-based assessment to enhance students' higher order thinking skills. She's also actively involved as a facilitator in national training program, served as an editor and reviewer for several academic journals, and currently acts as secretary of the master's program in educational management at UPGRIS. Please welcome Dr. Widya to deliver the insight. Good afternoon, Dr. Widya. Okay.
Wait a moment. I
Yes,
screen.
no problem. We will wait for you. Mom Widya.
You cannot share screen, please.
Okay, please ask me. Would you like to would you like us to help you share your screen, Mom?
Okay.
Udah fokus ya pada.
Apita, can you help me share
Yes,
screen?
please. Okay, I will help you to share your screen.
Finish.
Okay,
Share
I got it.
WhatsApp.
Thank you. I will help you to share your presentation, Mom
Okay.
Widya.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
First of all, let's say praise and gratitude to God Almighty for this power and guidance to us so that we can do together at the event International Joint Lecture Series on Mathematics Education 2025. The Honorable Dr. Supandi, the Dean of Faculty of Education, Mathematics Science, and Technology Information UPGRIS. The Honorable Professor Rian Hans, the Dean of Faculty of Applied Science and Mathematics Education, AAMUSTED from Ghana. Good afternoon, sir. Thank you for your coming. And the Honorable Head of the Mathematics Education Department, Dr. Muhammad Prayito. The Honorable Professor Ebenezer Bonya, the speaker of today's session. Good afternoon, Prof. Thank you for coming. Mrs. Camelia Alicia as the research speaker, and the honorable ladies and gentlemen who participate in the session. Good afternoon, everyone. I am Widya Kusmaningsih from Mathematics Education Department, FPM Pati UPGRIS. Today, I would like to share about spatial geometry for junior high school student based on local wisdom. Next. Next, Miss Agnita.
It's already set.
You can slideshow.
Okay, already.
Okay. Yes.
Okay, can you see the
My
slide forward here?
my voice clearly or not?
It's clear.
Okay.
Okay.
Okay. Spatial geometry for junior high school student based on local wisdom. Importance of spatial geometry in everyday life. The introduction, challenges in teaching geometry for junior high student, role of cultural or local context in education, and focus Central Java local wisdom as a medium for learning. Objective in here, introduce spatial geometry concept through local wisdom, enhance students' spatial reasoning and cultural awareness, design contextual learning activities based on local artifact, architecture and tradition, promote character, education and local identity. Why local wisdom? Builds cultural identity and pride, increases relevance and adjustment, encourages critical and reflective thinking, support Merdeka Belajar, freedom to learn initiative. Example of local wisdom in Central Java, Semarang, traditional house, joglo, this material, this indicator symmetry, shape, and 3D structure. And then wayang kulit, shadow puppet, plane geometry, rotation, and reflection. And then Borobudur temple or Prambanan, 3D modeling, scale, and transformation. And then batik pattern, tessellation, and symmetry. Wood making on reverse, buoyancy, geometry of whole shape, balance, and gereja belenduk. In here is belenduk kurz. Example of local wisdom in Central Java. This is belenduk kurz in all city on Semarang, and then wood making of river. And then Borobudur temple, and then traditional house, and batik pattern in Java, Central Java. Why mathematical ability? Mathematical power includes the ability to explore conjecture and reason logically to solve non-routine problems, to communicate about and through mathematics, and to connect ideas within mathematics and between mathematics and other intellectual activity. NCTM 1999. Mathematical ability is the ability to deal with problem both in mathematics and real life. Spatial ability, Gardner stated that spatial ability enhance object-related abilities, namely mathematical logistic intelligence that grows from the beginning of object to numerical compilation and kinesthetic intelligence. Manuel Albert, 2005, start the visual spatial intelligence relate to mathematics is the aspect of space, shape, and time. The aspect of the shape and space is closely related to geometry. What is spatial ability? Spatial ability is our everyday interaction with the world, our ability to plan a route, locate entities, and imagine objects from description of their arrangement. Example, A is on the right of B. C is on the left of B. D is front of C. E is in front of B, so D is in front of E. Spatial ability is the ability to see, observe, and reflect on spatial object, image, relationship, and transformation. Batista 207. The most fundamental stroke in geometry. This is spatial is a fundamental stroke in geometry. Spatial ability is the ability to produce and manipulate image. Involves several elements. One, holding visual pattern in memory. And two, comparing visual pattern. Three, performing mental transformation. And then manipulating internal mental representation. Spatial ability indicator. Ability to imagine and illustrate geometric object after rotation, reflection, and dilatation. Ability to determine the image object that correspond to a certain position from a series of spatial geometry objects. Ability to accurately predict the real from a spatial geometric object that is perceived in a certain perspective. Ability to determine the image of a simple object that is attached to a more complex image. Ability to build model relate to spatial geometric object. Ability to draw and compare the logical relationship of spatial from component. Ladies and gentlemen, this is spatial ability indicator, constructs indicator to measuring spatial ability, then mental rotation, spatial aspect of the curriculum, rotating 2D and 3D object clockwise and counterclockwise. And then item character determining the result of 2D and 3D object rotation. Difference between reflection and rotation. Spatial orientation, spatial aspect in the curriculum, orienting oneself in space, reading maps, corner point relationship, viewing from the front, above, or side. And then item character, determining the position of an object depending on the observer point of view. Reading maps from different perspectives, identifying the cardinal direction when not in is not perpendicular, identifying orthogonal viewpoint of an object. And spatial visualization, spatial aspect in the curriculum, symmetry, pattern, 2D and 3D shape, and their relationship, part, wall relationship, and reflection. Visualizing the result of the folding, unfolding, certain configuration, and then constructing geometric shape from given net vice versa, and the matching piece and part, finding the symmetry of an object, and then reflecting an object. Example of spatial ability question, and in here, cubic, the diagram below represent a model made out of cubic, rotasi mental, about object 3D. And then the diagram below show the next of a cube. Visualization spatial from the multi arah. Example of spatial ability question in local wisdom Semarang. This is a marabunta building in the old city. Attention, example question. Attention to the console part of the building marked in red. From the stimulus above, if the size of the console part is shown in the picture, then the slope value gradient of the console roof that follow the slope of PQ is, in here, the student can looking for a gradient. Spatial orientation. In here, the question about the map. Student can make a route from school to the house or from house to the school. The figure show empirical finding on question. Most students answer the question correctly. The spatial indicator on question is spatial visualization, namely the ability to understand the relation between objects in space, such as distance, orientation, and direction. When confirmed through interview, several objects said they did not know the direction from home to school, but were able to make a map of the direction from home to school correctly. This shows that the spatial visualization skill they have are good, but they are not yet used to it and have not been honed, so that students are not used to using this ability to solve problems in everyday life. Next, this is a mental rotation problem. The question, student determine the relation between two lines in a geometry figure. Questionnya, look at the following image. The figure show the correct answer from student who answered question. The next empirical findings show that students who have low rotation abilities with indicator determine the relation between lines in a geometric figure. The student is only able to analyze based on the image, but has not been able to see the image from various points in of view. It can be seen in the image that the line segment DC is shorter than the line segment AC. In fact, based on the information in the question that BC seem to be D. But in the image BD appears to be longer than BC. Students do not pay attention to the information in the question. Student only focus on the image. So student answered incorrectly. After being confirmed, though, through an interview, the student said that he saw the image as a rectangular plane figure. Jadi menganggap bangun datar. Okay, spatial and next spatial visualization. The question, this image is a section of the roof of the mosque seen from multi-direction. From off the side and the figure, it shows that the empirical finding of student answer to question with a complex multiple choice question format. Student can choose more than one answer option. Spatial indicator of question about mental rotation. With the indicator, student can determine the shape of geometrical shape if rotate in the question. Students are given a stimulus in the form of mosquito roof. Students are asked to determine the shape of the geometric shape when viewed for various directions. Students are able to answer correctly. After being interview, students said question was not difficult because there was a stimulus and they were used to seeing the roof of the building from multi direction. And most students answered the question correctly, so there was no difficulty. And then thank you very much for your attention, everyone.
Yeah. All right. Thank you very much, Dr. Vidya, for your informative
I'm
presentation.
sorry because my English not good.
No, that was great, Dr. Vidya. Thank you for sharing us with the knowledge of spatial geometry, and then you connected to the local wisdom in Semarang. It's pretty awesome to know it, particularly for our participants from abroad, from Ghana, Pakistan, Sri Lanka, and also for our students from Indonesia. All right. Okay. Now let's shift our focus to our second speaker, Professor Ebenezer Bonya. So he's from AAMUSTED, Ghana. He will share insight on the mathematical modeling of Buruli ulcer. Okay, what is that? We will explore more. So this is the context mixed method approach in a contaminated environment. But before we proceed, let's learn a bit more about Professor Ebenezer Bonya's background. So Dr. Ebenezer Bonya is a professor of mathematics education at Akenten, Appiah Menka University of Skills Training and Entrepreneurial Development, AAMUSTED in Ghana. He holds multiple advanced degrees, including a PhD in applied mathematics, and his research spans mathematical modeling, dynamical systems, optimal control, and ethnomathematics. So Dr. Bonya is internationally recognized, having served as a visiting professor in South Africa, Indonesia, and Ghana, and is ranked among the world top 2% scientists. Wow, that's wonderful by Stanford University and Elsevier. He has authored over 100 scholarly articles and has received numerous grants and awards for his contribution to mathematics and education. Please welcome Professor Bonya to deliver the insight.
Thank you. Okay. Good afternoon to everyone. Good morning to
Good morning, good afternoon from
my dean,
Indonesia.
Professor Jahans, and other postgraduate students from Ghana listening to this talk this morning. The title of my talk is Menka Modeling or Buriri Osa, the Context Mixed Method Approach in a Contaminated Environment. Typically, modelers, as far as I know, always interested in quantitative studies. But after I spent some time in mass education, I've realized that we could blend qualitative information to supplement quantitative studies that we do as applied scientists. God. So I start my talk. This is my profile. If you go to AAMUSTED, you can find me there. Here's the star profile. This is my Scopus profile. And this is also the AAMUSTED. This last one is the Google Scholar. So I start talking about introduction. I'm sure some of you may not have heard about borreliosa. In fact, it is one of the tropical neglected disease, which is caused by Mycobacterium oscillarium. In fact, BU is the most common mycobacterial disease neglected globally, which belong to a group called tuberculosis. But because it's normally affect poor people in the communities, society has not given the attention it deserves. Then the most worrying aspect of the disease, ladies and gentlemen, is that it's normally children between the age of 4 and 15. In Africa, if you look at the gender distribution of this disease, it is 52 male to 48% of female, because it is perceived that male have to work hard to feed their family. They get themselves interacting with the contaminated environment more than the female. So the point is, what drives the disease? We're saying that it is driven by speed environment change, coupled with deforestation, eutrophication, construction of dam, farming. But in West Africa, one of the threatening existential problem we are facing in this part of the world is called unapproved mining. We call them artisanal mining, which in the local parliament we call galamsey. These group of charlatans have managed connive with political elites in the society. People who Ghana has spent money to train some of them to come and mine the country for future generation have destroyed almost all our water bodies. And this is where these bacteria thrive. When there's a less oxygen in the environment, that is where the pathogen are able to thrive. So I'm saying that factors that affect the survival of the pathogen is the environment and its transmission. Epidemiological studies show that the microbacteriosis is mainly found in endemic waterlands and slow-moving rivers. So when you do mining inside river body, will the river move faster? No, because you're going to have sedimentations along the boundaries and then the flow of the river. And that is where this pathogen will now survive. So again, microbacterial Syrians survive best under low oxygen. So when you do this to environment, the content of oxygen in these stagnant, not moving water bodies is so low. And as low as they are, this is where this bacteria will survive and cause harm to. So the likely mode of transmission is driven by two processes. First, it occurred through direct contact. In fact, a study was conducted in Côte d'Ivoire, a nearby country to Ghana. It was then established that the disease can be transmitted from man to man through maybe if you have the ulcer, then the other person taking care of you has some bruise on the skin and the skin gets in touch with where the ulcer is, maybe through treating the wounds. You could be infected. Otherwise, what is known as far as literature is concerned is that it is purely driven by environmental, contamination. I've done a couple of studies in this regard. For example, Hotel, he hypothesized that he believed some small fish called mollusk harbor this bacteria and carry them along. And as man eats these small, bodies, they are likely or get in touch with, they are likely to get infected. That's one hypothesis Hotel has shown. And in fact, in some previous studies I did, I also hypothesized that water bugs, they are flies, normally are found around water bodies. They also carry this microbacterium along. And when they bite human beings, they are likely to be infected. So the most, for me, devastating effect of this disease is that when you get the ulcer, to treat it is through surgery. When the ulcer becomes very huge, you can't treat it unless surgery. Sometimes you have to do grafting. In other words, they cut part of the flesh of your body to go and fill that hole. If you're able to see it early, then you can use antibiotics to kill the bacterial ulcer. And normally people also believe that this disease is caused by myth, some spiritual realm. So when somebody gets the ulcer, everybody try to avoid getting in touch with the person. By the time you realize, you take the person to the hospital because they believe it's supervision. So they take them to sometimes spiritual hairs to heal them in the spiritual, which will not occur. And at the time you realize sometimes you have to cut that part of the body. So I show you some of the things I've said. You can imagine human being created by Allah or God who cause such a destruction to environment. And you want to have a better life. No. So these stagnant water body you are seeing here, they are not moving. And this is where you find this bacterial, surviving. So if children by chance happen to swim in these water bodies, disaster would likely to happen. And in Ghana, this is the kind of canker that we are facing. Ghana. I show you, sorry for showing you this unpleasant, pictures. But this is the disease I'm talking about, ladies and gentlemen. You can see a young lady, a young girl. Look at what the disease had caused her life. Look at this. Look at this cow. So it shows that as a society, there's a lot to be done. You should not allow few people in the society because they want to become wealthy, not through the right cause, through every appropriate means to get wealthy at the expense of the global interests of society. So Why am I even worrying myself, dealing with mixed math? Like I said, as an applied scientist and also as a mathematical educator, because I have first degree in maths education, I have masters in education too. And therefore, I know my ins and outs also in education. But the previous studies have been concentrated around on applying maths in mathematical, biological processes, social processes. For example, I've done some studies in modeling corruptions, and modeling financial activities, a lot. But I feel that it has come to a time that you should blend the quantitative studies with some kind of qualitative too. It's like a supplementary or complementary kind of information to check what data sometimes give us is actually the reality on the ground. Having, implement with data. So mixed approach, which is the modeling the infectious using differential equations. In this case, I'm going to use what you call fractional differential equation. So I'm combining quantitative and qualitative to get insight into this canker. So ODE based on provide rigorous mathematical framework. In other words, it's going to give me the model, the kind of model that I want to propose based on the available literature that I've consulted. The qualitative aspect through interview, through observation, will also help me to validate the parameters that have been used in these studies. So it is not a fluke or by chance that this study sought to combine qualitative and quantitative approach, as a modeler. So, like I said, Conan et al. 2019, they carried extensive study in a nearby country called Cote d'Ivoire. And what did they do? They wanted to see whether the hypothesis people or perception people have about the transmission infection of the BU could be true that when an infected person get in touch with an innocent person, susceptible person, through maybe the person's skin has some kind of bruise, then I'm treating somebody with that ulcer, maybe cleaning the debris on the ulcer using wipes and so on. If it gets in touch with my skin, can I have the disease? So this study was carried out and it was found out that even though not in large proportion, but some of them got the ulcer through contact with the infected patient. So in this study, that is the new thing that I've incorporated. I have now incorporated the effect of human to human transmission to the existing literature, which is transmission through what environment. So in this model, I look at transmission through human contact, and based on this perspective, I incorporate the human possibility infection route and put together have my total human population as N of T, have my susceptible population or individual, those who are virgin, they have never been exposed to the disease as this, and then those who are exposed to either get in touch with those with the ulcer by maybe a person who is helping the person in the hospital, in the home, treating the disease, or getting in touch with environment. Then you also have infectious individual. Now they have the disease, they are very infectious, they can infect somebody. Then those who are infected and are going through treatment in the hospital. Because now there's a very vibrant education. Most of these communities in Ghana, we talk of Amansia West, Amansia East, where the disease is very prominent. The WHO has invested a lot of money through public education to educate people the need of preventing or early reporting of the disease to hospital. Then those also are recovered. Then I also have a compartment called the density of microbacterial pathogen that can be contained in a given environment. Based on this, I show you this schematic diagram. This is susceptible. This is the recruitment rates. So this function you see here are two routes. This is driven by those infected. This is the contact rate. This is the carrying capacity, K. This is also driven by the rate at which people get in touch with the contaminated water bodies and what have you. So this is the susceptible. So when this susceptible compartment gets in touch with this, it can, or the probability that it can result into infection is what we are seeing here. Then they move it to what? Exposed. Some people may be lucky. It may be through the immune system, what have you. They could be exposed. They may not get infected. So those who get infected, they move to the infection rate at this theta. So they are here. So when you get infected, then the family or your close people around you will likely to convey you to what? Hospital for what? Treatment at omega rate. So when you get treatment, the treatment is good, you respond to treatment, you take your drugs, you do whatever you're supposed to do, you are expected to, recover at this rate. So now you get recovery. Here, let me come back again to this rate. So you see here is dotted lines. It's not like this. The reason is that here is the shading rate. So when you cut the ulcer, the ulcer, dead part of the body, you are treating, you are clearing away. Where do you clear it away? To what? Environment. When you clear them back to the environment, the pathogens are not dead. So they go back to stay there if they are not well treated. So that is why from this density of the concentration of the microbacterium, they get in touch with the environment, society will get in touch with the environment, the cycle continues. So when you recover here, you can lose immunity because you are recovered from disease and you don't take the precaution, what you have the do's and don't, you are likely to become susceptible again, you get infected. Then you saw that we have one of them, I think this is what you call the natural mortality rate. This data is the disease-induced, rate. So, ladies and gentlemen, having shown you the compartmental model, I would like to show you the model I formulated out of this interaction. And this is fractionalized model. This is based on a Tangana-Beleno operator. I chose this operator because one, it's non-local and also non-singular. In other words, the kernel of this operator is able to stretch to one another operator, helping it to predict better. And one characteristic about fractional calculus is that it has two things which you can never take away. One of them is that it take into consideration what has happened in the past. What I'm sure you have heard memory effect. And then you take in consideration what is happening now to predict. In life, in history, if you don't know your past and you don't take into consideration your present, you are likely to predict wrongly in future. And that inspired me to leverage my study mostly on this operator. So as dynamical system I'm interested in the invariant region. In other words, with which region is my solution is confined. In other words, what is my universal solution or set if you put in the basic set theory? So this is a bounded solution of my study. Having obtained that, this is reproductive number. I used the next generation matrix approach to derive, which was proposed by Watmoff and co. It has become one of the best methods in estimating reproductive number. What does it do? You take into consideration the infective compartment, and then you have the entering, in other words, the interaction of entering of the disease into the system, those living, then you have your F and vein, you find the Jacobian metric respectively for each of them. Then you find the inverse of F, you multiply, inverse of vein, you multiply by F. Then you take the eigenvalue, the largest ratio that eigenvalues give you the reproductive number. So ladies and gentlemen, this threshold explains how many can one infected person infect in the virgin population. In other words, how many can infected person infect susceptible? If one infected person can infect 5 people, then that is the R0 we are talking about. Now, also interested whether the system has a equilibrium solution. If it doesn't have a equilibrium solution, then I will be worried because I cannot determine how this disease dynamics is likely to behave in the long term and the short term. So I equate all the infection compartment into zero and solved and obtain this solution. Then I equate all the compartment into zero and solve. This is where Birosa in the community. So what is the solution? And I obtain this solution respectively. So I'm also interested to look at the local stability of the system. What did I do? I just leveraged on Jacobian metrics, this Jacobian metrics looking at whether I'm going to have all my eigenvalues being negative. When they are negative, I can conclude that it is locally asymptotically stable. When I did, I found out that 2 of them technically are negative. So you could see I have 5 compartments, 1, 2, 3, 4, 5, 6. Yeah, 1, 2, 3, 4, 5, 6. I have 6 compartments. So 3 originally 0, but the other 3 were not, 3 originally negative. The other 3 were not negative. So I use Royal technique and obtain a characteristic equation you can see, and use the characteristic equation to conclude using Royal's criteria of stability to conclude. And I did the conclusion and found out to be. In fact, in this study, I also have global stability, but for purpose of presentation, I didn't include them. Global stability for disease-free. I did global stability for endemic too, but I have not included them. So because this disease deals with environment, so I was also interested to look at the fluctuations. Does weather have effects on the spread of the disease? Which it is. In the dry season, a lot of people get this disease more in the community. So I incorporated stochastic. And this is the stochastic constant. So this is the Brownian standard motion I incorporated in the model. Then I tried to study the uniqueness and existence solution using Lipschitz conditions. So my study seeks to establish this condition to be existed in the study. So I rewrite my solution in this form. So I start to establish the first condition. So this is a mathematical rigorous proof that I did. So, and at this condition, I conclude. Maybe because of time, I want to be very quick. Then I did all of them. Then when I got done, I conclude for the first Lipschitz condition. Then I came back to the second condition, where I'm more interested in only the compartment perspective. So if I have maybe a compartment, then other terms are not part of that compartment. I do not consider. So I consider each compartment that has something to do with that compartment only. So I did that also, respectively, all of the terms I did. And finally also conclude that that condition has also been established. Once it's established, I can conclude that the solution is unique and also in existence. In other words, the solution exists, so has a unique solution. Then that was not the only thing I did. I went further to also incorporate fractional time optimal control. So here I incorporated a control called public education, because I realized that people are very interested in money, but money is everything. We don't know. And sometimes, as a society, we need to educate people to see the relevance of maintaining environment. And if you have money, you have everything, you don't have life. What is the use of your money? So it was one of my control strategy. I also incorporate another control strategy to educate people who have the ulcer, how they should dispose the ulcer into the environment. Then I also put a control on the drug efficacy. This is a control track. This is my functional objective I set out. Then, in fact, I didn't show. I had what you call it, the adjoint equations or the characterization. Based on it, I obtained my solution, control solution. And I tried to, do some simulation based on modify Adamboff numerical scheme in a Tangana, perspective. So because of time, I'll share a few of them. So here you could see that I activated control 1, which is the public education. Control 2, let's see control 2. You can even see for yourself. What's control 2? It's also education. So let me see if I automate 2 education, 1 for general people, 1 for those who have the disease, how to dispose the ulcer, the breast, and so on and so forth. You could see that the control profile. The control 3 is totally not active, 0. That is why it is down here. I can see that control 1 was active for 5 continuous days, maximum 100%. Then after that, we saw that it was giving us what we want. So we reduce it drastically within the 20 days of intervention period. While control 2 was kept as much as 10 continuous days. Then after that, we also reduce its effect, because don't forget, this control you are seeing here, it comes with a cost. So if you optimize this for 100 days, you must also prepare pay. So if you give you optimize, you can reduce cost. Because it's cost, we are minimizing cost, we are maximizing what? Reduction of what? Infection. So this is the environment. You could see that when this control was put, the density of the microbiota was drastically reduced compared to when there was no control. It means, therefore, practically that a control strategy is what? Effective. Similarly, this is the infection compartment. You could start giving public education to the general population, giving education to those who have infected, shows the total reduction of the disease as compared to without any control. Then also look at another control. This time we targeted public education and drug efficacy. We can see that there's no public education for those who have been infected. So that is the control 2, the red line down. Then the green is being optimized for 2 and 5 days as usual, while control 3 was optimized as many as 18 continuous days. Okay, so that shows that the control that shows the control profile. Now let's look at the dynamics. You can see that there's a reduction. There's a reduction in the spread, the density. Just a second.
Excuse me,
It's okay. It's okay.
we have 2 minutes more.
Okay. Let me conclude. So
Okay.
similarly,
Bye.
we did all this as we done here. Then this is where the stochastic perspective. So also put the stochastic constants in the modeling, this simulation. You see that there's some fluctuations in the solution. That shows that it's not stagnant. It depends on the situation at the time. We did that, and then we also put qualitative data. And we interviewed 3 experienced nurses in the community based on the results we obtained in optimal control. We use that to ask questions to confirm or otherwise. So that's also because of time. For example, maybe let me share only one of them. For example, nurse 1 representing the nurse 1 represent the first participant, and 2 represent this. So the interview were used to gather data to confirm. So here I use content analysis. So for example, I asked Team 1, social awareness campaign and treatment and drug efficacy as a control strategy. So I went back to the field and asked the nurses. So for example, I asked nurse 1, it says social awareness has been the basic information platform on BU for past 8 years. Human beings can transmit a BU, but not common. So you see, I've seen that. I want to confirm based on my results. So this was done to supplement the results obtained, in the quantitative study. Because of time, I could not share those things. I just want to. So in this presentation, I've tried to blend quantitative and qualitative study. I've tried to show the gap between the existing literature with respect to the transmission dynamics of disease, which now incorporated human-to-human transmission. Have also the first time perhaps to incorporate qualitative data or analysis in line with what this model. And I also use fractional modeling. I consulted some few references here, and I say thank you, Midas, in my language. Thank you. I'm done.
Thank you very much.
Thank you.
Medamo Aze. So this is Ghana language. Medamo Aze.
Yeah. That's thank you in my language.
Okay, wonderful presentation, Prof. Punya. So we know about the connection, mathematics, pure mathematics for solving the problem. So I just noticed that Puruli is kind of disease, right?
Yeah.
Interesting. Okay, ladies and gentlemen, we are focused on the third session. Okay. Now let's shift to our third speaker, Miss Camelia Alisa. She's from UPGRIS. She will share insight on the fostering students' mathematical critical thinking through a STEM-based water filter mitigation project. So this is part of her paper. But before we proceed, let's learn a bit more about Miss Camelia's background. So Camelia Alicia is an 8th semester mathematics education student at UPGRIS with a strong interest in education and data analysis. She has hands-on experience in data science through the study independent program at Celebrates, where she worked with Python, SQL, and Tableau. Camelia has also contributed to educational research on STEAM-based disaster mitigation tools and participated in Campus Mengajar, helping improve literacy and numeracy in schools. She actively engaged in students' organization and has held leadership roles in Himatika UPGRIS. She's also demonstrating her commitment to both academic and extracurricular experience. Please welcome Ms. Camelia Alicia to deliver the insight.
Thank you, Ma'am. Thank you, Ma'am Agneta, for the opportunity. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
The Honorable Professor Punya, and then the Honorable Ma'am Widya Kusmaningsih, and the Honorable all participants in lecture series today. Before starting my presentation, let me introduce myself. My name is Camelia Alicia. I am from Universitas Persatuan Guru Republik Indonesia Semarang, or UPGRIS. Today, I'm going to present about fostering students' mathematical critical thinking through a STEAM-based water filter mitigation project. So, the introduction of the first about educational challenges 21st century. Experts in the field of education state that in the 21st century, students must have 6 skills. There are critical thinking, collaboration, communication, creativity, citizenship, and the last, character education. Of the 6 skills above, critical thinking ability is one of the skills that must be instilled in students from an early age. But Indonesian students' critical thinking skills are low. This is proven by the 2018 PISA and 2011 TIMSS score in Indonesia, which are relatively low. One way to improve students' critical thinking skills is through learning mathematics. However, there are still many students who have difficulty learning mathematics. And then students' difficulties in learning mathematics. The first is about find mathematics difficult and scary. The second is difficulty connecting concept with the real situation. Based on the background above, what is the solution? So the solution is to implement STEAM-based contextual learning. STEAM-based contextual learning allows students to be directly involved in the design process, produce product, develop creativity, and improve abilities through relevant and writing programming. Is able to improve students' critical thinking skill by providing time and opportunities, both individually and in groups, to solve problems related to their respective environment. Example of a problem that often arises in the environment is related to disaster mitigation effort. In Indonesia are vulnerable to disaster. So it is important to introduce disaster action to students in order
Recording
I
in
choose
progress.
cluster random sampling. There are 7A as the experimental class, and then 7B as the control class. And the research step, number 1, observation, number 2, implementation, and then number 3, evaluation. And the instrument, there are ESI, to measure critical thinking abilities, and also students response questionnaire. Students response questionnaire containing 3 aspects, namely aspect of mathematics ability, aspect of mitigation STEAM-based learning, and also aspect of critical thinking skill. For the last is data analysis. Number 1, descriptive statistic, and then normality test, and then homogeneity test, and also t-test. For the research and discussion, in the project learning process, students include complete activity design that are appropriate to a STEAM mitigation-based project that is integrated EDP or engineering design process steps. Then, students integrate the STEAM mitigation concept into one variable linear equation and inequalities material through the water filter project. And then, what is water filter? Water filters are made using used plastic bottles arranged vertically and filled with various layers, such as cotton, gravel, stones, charcoal, and sand, to filter dirty water. Students are free to determine the arrangement of filter materials according to their ideas and creativity, so that each project created can be different design variation. For the next, after learning through a STEAM mitigation-based project, students are given post-test questions to determine their critical thinking abilities. The post-test question presented contains 6 indicators of critical thinking according to Ennis. We know it as Frisco. There are focus, reason, inference, situation, clarity, and the last is overview. Before the post-test is distributed to students, expert validation and readability testing are first carried out. The post-test questions are in the very high category with a validity level of 0.93. The type of readability test use a limit readability test, where the evaluation is carried out on a small scale to identify students' difficulties in understanding the question. And then the average post-test score for the experimental class was 70.69, while the average post-test score for the control cast was 56.21. After the normality and homogeneity tests were failed, it was continued with the t-test to obtain a significancy value. There are 0. Then, what are the results of the students' response questionnaire? Most students strongly agree that number 1, the water filter project increases understanding of PLSV and PTLSV concepts. PLSV is linear equation in one variable, and then PTLSV is linear inequality in one variable. Number two, increases motivation and awareness toward mitigation. And then number 3, able to improve 21st century skills, especially critical thinking. We got the conclusion. The research results show that the steam mitigation-based water filter project is effective in improving students' critical thinking skills, and students' responses to the learning are in the positive category. Students not only understand real mathematical concepts, but also develop their skills in identifying problems, designing solutions, and initiating and improving their project plans. Besides critical thinking, this project also strengthens other skills such as creative thinking, collaboration, and communication, as well as increasing awareness of the importance of disaster mitigation and protecting the environment well for sustainable living. Thank you much for your attention. The last I say, wassalamualaikum
Waalaikumsalam
warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh. Thank you, Miss Camelia, for your insightful presentation talking about the STEAM mitigation. So this is kind of study that integrating STEM and how to tackling the disaster using the mitigation education to the students. All right. So we come to the session, an interactive Q&A session. So I will invite anyone of you here to engage to ask the question to our distinguished speakers today, or you can also type your question in the chat box. Okay. Miss Vivi, could you help me to spotlight all the speakers? Okay. Ma'am Widya, could you please open your camera, and Professor Bonya, could you please open the camera, please? Okay, we will check on the chat box first. Okay, we have a question from Sir Sarhan.
I'm here.
Okay. Okay. Prof. Bonya is here. Are you with us?
I'm here.
Can you please open your camera, sir?
Oh, I should open my camera. Oh, okay. Just
Okay,
a
thank you.
second.
We will spotlight.
Just a second.
Picture. Yes, please. Okay. So we have a question from participants Buddha Sarhan. Hello, sir. Thank you for your
Hello.
nice question. Okay, so the question I think is for Professor Bonya. How we find the stability of a disease from the graphical approaches? Please let me know about this. Please, Professor Bonya, to respond this question, asking about the finding the stability of a disease.
Using graphical approach. Okay, you could do that by sometimes taking some initial conditions, some parameter values, and then you run, maybe you could do it MATLAB or Mathematica. Then you do same plots, another set of parameter values, another set of initial condition, and see where the trajectory move towards. If they are all moving towards a certain directions, then it gives you fair idea numerically the stability of the system. Yeah. However, I normally don't recommend numerical stability because it could deceive you. Front. It could deceive you because if you change the set of parameter values, it could give you another trajectory. So unless otherwise, I prefer you do the stability using analytical approach, and then you solve, whether confirm or otherwise. Thank you.
All right, thank you. Professor Punya has already explained to us the procedure to find the stability of a disease from the graphic. Does it clear enough, Sir Mudasar? Or do you want to respond?
Not clear.
Okay, thank you. Wonderful. I would like to remind all the participants to fill the form for attendance list that has been spread in the chat box. Please fill the form to claim your certificate of participation today. Oh, we have another question from Aurora Nur Aini. Please, okay. Hi, Mr. Bonya. That is a very good study. From the transfer diagram, what is meant by compartment M, and what do the dotted lines to and from this compartment mean? From the result of the study, what can you suggest to prevent the spread of this virus? Have you published the research? I would like to learn more about it. Wonderful. Ma'am Aura is one of our colleagues in UPGRIS in Mathematics Education Department, Sir Punya. She's also focusing in mathematics modeling. Maybe in the future, you both can make a collaboration in a writing paper. Professor Nya, are you still with us?
I am.
Yeah, okay.
Hello? Yeah, I heard.
Hi.
If I heard you right,
Okay.
I heard you right. The participant is asking the dotted line from the schematic diagram. What I explained, what I explained is showing the rate at which those infected get shaded them also onto the environment. Because infection group shade the browser into them. That is why in the optimal control, I put public education to those who have also how do they professionally dispose this also onto the environment so that the spread will not be much in the communities. And I showed the control. Unfortunately, there was not much time for me to, explain all the control dynamics. However, those I showed, for example, the control one strategy where public education was given to the general population, and then those with the specific OSA, you saw that there was a total reduction of the OSA into the community. And again, he was also talking about how can we incorporate this into, modeling in education. In fact, That is one area of my research that I'm embarking on. I am trying to see how modeling can aid in what you call critical thinking, problem solving, which modeling is one of the higher order of problem solving. And therefore, when people are able to do modeling, it means they have a very strong background in problem solving. And therefore, they can model real life problems, solve, and make mathematics more practical, relevant to everyday's life. Thank you.
Wonderful. Thank you for your extensive explanation about what's that, the compartment itself. So this is pretty closely related to the application of mathematics to solve the problem related to the disease. Ma'am Aurora, do you have any further question or discussion to respond, Professor Bunya? Oh, maybe about the paper, Professor Bunya. Would you mind to share your paper related to this study? Professor Bunya?
Hello. This paper is yet to be published. It's not yet published, but I have other Briosa related papers that they can find from my profile, or they can send me personal email. I can share some of my previous works on Briosa. This one is yet to be published, so it will be difficult to share the full, manuscripts.
Okay, no problem. Okay, thank you. Okay, thank you, Professor Bunya. We have another question, and I think I also saw the participants raise hand. Miss Rahma Hafidah. We also have a question from Ma'am Dewi. Okay. Okay, we will proceed with Ma'am Dewi question first. Hi, Ma'am Aknita. Let me address a question to Dr. Widya. Okay, from Ma'am Widya. How to bring local wisdom into the learning process? Through what? Is it a project or maybe through material exploration? So that students will feel close to reality, and also it will provide good implication for achieving special abilities. Ma'am Widya, are you still with us? Because she said that she will continue the travel. Ma'am Widya, you still with us? Okay, while waiting for Ma'am Widya joining to us, I will also invite the participants to join in the interactive session for the question and answer. Okay, Miss Rahma Hafidah.
Yes, Mom.
Okay, I saw you raise your hand. Please, you can ask the question and address to which speaker.
Okay, my name is Rahma Fido from University PGRI Semarang. How might this team-based approach be adapted for academics or levels? Address the question to Miss Camelia.
Okay, so the question is addressed to Miss Camelia. Okay,
Thank you, Ma'am.
Would you repeat your question?
How might this team-based approach be adapted for other mathematical topics or grade levels?
Oh, all right. Thank you for such interesting question. So, Ms. Rahma Hafido is asking about how might this team-based approach be adapted for other mathematical topic or grade level, since Ms. Camelia shared that this is part of junior high school curriculum, right? So, please, Ms. Camelia, to respond this question.
Thank you for the question. In my opinion, This team-based approach can be adapted to various mathematical topics and grade level by aligning project with curriculum goals and real-world context. For younger students, hands-on activities like building models can introduce basic concepts, while older students can engage in more complex projects such as data analysis, budgeting, or architectural design. Topics like geometry, algebra, and statistics can be explored through interdisciplinary projects using local issue or technology tools like GeoGebra or Tableau. This approach enhances critical thinking, creativity, and collaboration across all levels of education. Thank you.
Wow, wonderful. Thank you, Miss Alisa, for your comprehensive explanation. So from her explanation, we know that the application, the implementation of STEAM mitigation itself also can be expanded into any other topic such as statistics, algebra, geometry, also using the local wisdom as well, as this is also in line with Dr. Vidya research, that is the using of local wisdom will help the students to be more understand about the concept itself. Okay. Okay, Miss Rahma Hafida say thank you, Miss Camelia, welcome. Okay, thank you. We still have one question from Devi. I would like to invite Mom Vidya. Are you still with us? Okay. Okay. All right. I think okay, Mom Vidya is coming. Okay, Mom Vidya, we have a question from Mom Dewi. Hi, Mom Agnita. She's asking about how to bring local wisdom into the learning process. Through what? Is it a project or maybe through material exploration? So that students will feel so close to reality, and also it will provide good implication for achieving special abilities. Okay, we will spotlight Mom Vidya, please. Okay. Okay, thank you, Mom Vidya, for joining us during your travel. Okay,
Okay, thank
so
you for
how do you bring the
Agnita.
local wisdom into the learning process?
My voice is clear or not? I'm sorry, I'm in the toll.
Yes, the highway.
Okay, Miss Dewi question. How about Miss Dewi question?
So she's asking about how to bring local wisdom into the learning process. Does it through the project or the exploration?
Oh, student can talk the project, and student can vacation pusing-pusing, keliling-keliling.
All right. That's nice.
You can talk the project and student vacation. And in
Okay, thank you, Mom Vidya.
all city in the Semarang,
Mhm.
many building can spatial geometry, for example Gereja Belenduk, and then Lawang Sewu, and then a lot of building. Can you explain? You make the building is for study geometry about spatial.
Okay, great. Thank you, Dr. Widya, for your nice explanation to let us know about what's that? The historical building in Semarang, such as the Gereja Belenduk. So
Gereja
this is kind of
Belenduk, and then
church, the landmark in Semarang, the historical building in Old City Semarang. So this is quite interesting for the students to learn mathematics, particularly in spatial geometry, because they have to be involved in the project itself, and then through the excursion and vacation, they will sightseeing around the Semarang to see the local wisdom itself. All right, thank you. We could have the further, what's that, explore many collaboration with other partnership, talking about the ethnomathematics itself. Okay, we will check if there is any other question. Okay, I think that's all. Okay, ladies and gentlemen, esteemed guests and distinguished representative, we come to the end of this session. Thank you to our esteemed speakers, Dr. Widya, Professor Bonya, and Ms. Camelia, for your sharing the expertise, and to all the participants for your active engagement. But before we
hilang.
officially close this
Internet
event,
hilang.
we will now proceed with the
Oh, nggak ada
presentation
sinyal.
of certificate
Mati.
of appreciation to our distinguished speakers. To honor our distinguished speakers, we would like to present certificates of appreciation to Dr. Widya Kusuma. Could you please, Miss Vivi, to share the certificate of appreciation to our distinguished speaker? Okay, we will wait for Miss Vivi sharing the screen of certificate. Belum muncul. Okay, we will wait for Miss Vivi to share the certificate and handle it to the speaker today. All right, so this is to certify Dr. Widya as our
Recording
research
stopped.
speaker today. Thank you for your sharing, Mom Widya. And then we will continue to
Okay.
handle the certificate for Professor Bonya. Okay. Professor Bonya, kindly to receive this certificate. Thank you for your insightful presentation. And the third one.
Thank you very much for
My
giving
pleasure.
me the opportunity to be part of this wonderful,
No worries.
event.
Thank you very much for
I'm
your
very grateful
sharing.
to your university. Also giving time of his busy schedule to be part of this event.
Sure.
I wish they will not be the last day. I hope next time I will present something on mass education to the community. Thank you once again.
You are most welcome. Okay. And the last, we will handle the certificate for Miss Camelia Alisa. Kindly to receive this certificate. Congratulations to present your paper. Okay, thank you for your nice sharing about STEM mitigation project. And I would like to say my thank you, appreciate for your sharing, congratulations, and thank you for your invaluable contribution to the knowledge in mathematics and mathematics education. With that, we officially conclude the International Joint Lecture Series in Mathematics and Mathematics Education 2025 on May series. Thank you everyone for your participation. We look
Recording
forward to
in
seeing
progress.
you at our next academic event. Have a great day. Assalamualaikum warahmatullahi wabarakatuh. Thank you everyone. See you on the next event in mathematics education. Thank you, Mom Widya. Thank you, Miss Camelia, and thank you, Prof. Punya.
Okay, thank you, Pak.
Thank you, Prof.
Okay,
Punya.
I would like to remind all the participants who still here in the group WhatsApp to fill the link attendance form. Thank you.